Jane Morris, and today I'll take you through the risk assessment of herbicide-tolerant maize for general release and cultivation in southern African countries. Now, before you watch this presentation, you should first go through the presentation on herbicide-tolerant maize for food and feed use. In that video, I give much more background on the different types of herbicide-tolerant crops that are available, how they work, and also much more detail on risk assessment for food and feed use. So today I'll be focusing more on other aspects of a risk assessment that are important to take into consideration before a decision is made to approve general release and cultivation. We'll briefly cover what different types of herbicide-tolerant maize are already grown around the world and also in southern Africa, and how do we go about assessing the risks for human health and the environment. We go through the full risk assessment for one particular type of herbicide-tolerant maize as an example, also taking into account risks associated with the use of the herbicide itself. And then I'll briefly discuss issues with respect to management of emergence of herbicide-resistant weeds. Many different types of herbicide-tolerant maize are cultivated around the world. This includes more than 20 unique transformation events that have been approved in various countries. In some cases, other genes were inserted at the same time and through the same transformation event as the herbicide tolerance gene, most often genes for insect resistance. But in other cases, new combinations of genes have been derived by conventional crossing, often leading to complex stacks with multiple genes. In this presentation, we're not going to focus on stack traits, but rather on herbicide tolerance genes in unique transformation events. South Africa is the only country in the region that has already approved herbicide-tolerant maize for commercial cultivation. 4 events containing herbicide tolerance genes have been approved. First, we have NK603, produced by Monsanto and containing a gene for tolerance to glyphosate. This is marketed as Roundup Ready maize. It was approved in South Africa in 2002. GA21, approved in 2010, is produced by Syngenta and is also tolerant to glyphosate. Then we have BT11, also from Syngenta, that does contain a gene for tolerance to the herbicide glufosinate, but this is expressed at a low level and the tolerance of the plants to glufosinate is not high enough to be of any practical use. It is marketed only for its insect resistance. It was approved for general release in 2003, but the approval was subject to an appeal from the NGO BioWatch in 2004 that was eventually rejected and the marketing approval went ahead. And finally, there is TC1507, which was approved more recently in 2012. It comes from Pioneer and is tolerant to the herbicide glufosinate as well as being insect resistant. I'm going to take you through a risk assessment example for one herbicide tolerance maize known as T25 and marketed as Liberty Link. I selected it in part because it only has herbicide tolerance rather than both herbicide tolerance and insect resistance. Since I covered the risk assessment for insect resistant maize in a separate presentation, today we just want to focus on herbicide tolerance. I also selected it because it's tolerant to the herbicide glufosinate ammonium, so this provides an example for a different herbicide tolerance trait from the glyphosate example I used in the presentation on food and feed assessment of herbicide tolerant maize. T25 has been approved for cultivation in quite a number of countries as shown here, and it's also been approved for food and feed use in South Africa. But as far as I'm aware, there's never been any request for general release approval in South Africa. It was first approved in the USA back in 1995, so it's been on the market for over 20 years, and as an early approved event, some of the tests that were done differ from current regulatory requirements. T25 contains the PAT gene, coding for the enzyme phosphinothrycin N-acetyltransferase, from a common Streptomyces soil organism. It is expressed under the control of a cauliflower mosaic virus 35S promoter. The PAT gene acetylates and inactivates the herbicide. Some other instances of glufosinate-tolerant crops contain the BAR gene, which is homologous to PAT and carries out the same reaction. T25 also contains an incomplete sequence of a gene coding for resistance to beta-lactamase antibiotics. The native PAT gene was codon modified to increase expression in maize, and a plasmid containing the gene was introduced into maize protoplasts using a direct uptake technique with polyethylene glycol. The transformers were selected based on their tolerance to the herbicide. It was shown that a single copy of the PAT gene was inserted, but that an incomplete antibiotic resistance gene from the plasmid had also been inserted, as I mentioned previously. However, this was missing around 25% of its sequence and it was non-functional. The average expression levels of the PAT protein in grain ranged up to 0.43 micrograms per gram of dry weight. Field trials were carried out in a range of environments, and compositional analysis showed no significant difference from its conventional counterpart. The T25 was treated with glufosinate in the trials, so that any impact of the herbicide treatment on composition would have been seen. Now, because I already covered food and feed safety assessment of another HT maize event in a separate presentation, I'm only giving a short summary here of the findings for T25. The inserted protein gave no evidence of allergenicity. Toxicity studies were carried out in rats using a 14-day repeat dose methodology rather than the single-dose acute toxicity method that is more commonly used according to OECD guidelines. However, no adverse effects were seen. A 42-day feeding study with broiler chickens showed that T25 was nutritionally equivalent to the conventional counterpart, and a ruminant feeding study was done with maize silage that also gave similar results to conventional maize. This study was done because T25 is a yellow maize primarily marketed as an animal feed. There was no 90-day rat feeding trial done because this was not a European standard at this stage, and there were no negative indications that would suggest a need for it. However, there is one rat feeding study that was published in Russian, where they looked at 3 generations of Wistar rats and showed no impact on progeny development. So in conclusion, we can say that no hazards were identified that would make the maize unsafe for food or feed. Since T25 will be treated with glufosinate, we also need to consider the food safety of any glufosinate residues in the maize. Codex has set allowable maximum residue levels at 0.05 milligrams per kilogram for glufosinate and its metabolites, which would include the acetylated inactivated form of the herbicide. However, in most cases levels are well below this, particularly since the herbicide treatment is not normally applied close to harvest. Interestingly enough, glufosinate residues are more of a concern in potatoes and peas, where the herbicide is applied pre-harvest as a desiccant. The Food and Agriculture Organization recommends a maximum acceptable daily intake of 0.01 milligrams of glufosinate per kilogram body weight. But even if the residue level was at the Codex maximum, which is highly unlikely, a person would need to eat 12 kilograms of maize a day to reach this intake level. So in conclusion, we can say that the risks from consumption of glufosinate on the maize are extremely low. Moving on to the environmental assessment, we look first at agronomic performance. Field trials that were carried out in the US and in several European countries showed no change in phenotype or in any other agronomic characteristics other than the introduced trait when compared with the conventional counterpart. There was also no increase in weediness or invasiveness potential. One concern for general release of GM crops is the potential for gene flow, either to wild relatives or to conventional non-transgenic plants. But in this case, maize has no wild relatives in southern Africa, so horizontal gene flow is not possible. Of course, gene transfer to conventional maize is possible. However, maize pollen is heavy, so it doesn't travel far, and it's only viable for 1 to 2 days. Extensive tests have shown that there is less than 0.5% cross-fertilization at distances over 50 meters. So by keeping the GM maize at least 50 metres from conventional maize, any GM content in the conventional maize would be well below a threshold of 0.9%, which in Europe and in some other countries is the level above which labelling is required. In South Africa, the threshold for labelling is 5%. This, of course, is not an issue of safety, but rather an issue of consumer rights to know, since gene transfer to conventional maize would not result in adverse effects to human health or the environment. Another environmental concern is that cultivation of T25 would increase the use of the glufosinate ammonium herbicide. Glufosinate has a half-life in soil of around 40 days, and although it will certainly leach into the groundwater, long-term persistence is unlikely. From the perspective of biodiversity, it's interesting that farm-scale trials in the UK showed that herbicide regimes used with T25 resulted in increased botanical diversity compared with standard herbicide programs used on maize. And this fact was specifically mentioned in the European Food Safety Authority assessment of T25. Glufosinate does have some toxic effects and has been associated with neurotoxicity. However, we have to consider that risk is relative and has to be determined in comparison with other herbicides that would be used on conventional maize. One common herbicide used on maize in southern Africa is atrazine, which has been banned in Europe due to health and environmental concerns and can persist in groundwater for many years. Looking at the benefit side of the equation, use of herbicide-tolerant maize encourages introduction of low-till or no-till farming, which preserves the topsoil and avoids runoff into watercourses. However, one problem with the increasing popularity of herbicide-tolerant crops is the development of herbicide-resistant weeds. Some glyphosate-resistant weeds have already been found in South Africa. One problem is that there are only a limited number of herbicides available, which limits the possibilities for rotation, and farmers also stimulate resistance by not adhering to recommended dosages. The recommendation is that farmers should integrate chemical and non-chemical weed control rather than relying exclusively on chemicals. The chemical industry is taking this matter very seriously and has set up the Herbicide Resistance Action Committee to give advice on how to manage herbicide resistance. I give the link to their site here for further information. Returning to the assessment of risk for T25, we can say that no hazards were identified for T25 itself that would lead to significant harm to humans or the environment. While there are some hazards associated with the use of glufosinate, these are not likely to result in harm given the likely exposure levels. The overall risk is therefore very low. There is, however, one more aspect that might be considered, and that is the issue of socio-economic impacts. Every country decides according to their legislation whether they will take socio-economic impacts into consideration, and of course these may be either negative or positive. A lot has been written about the difficulties of carrying out socio-economic assessments, particularly ex-ante assessments, that is, ahead of any approval. There's no clear methodology, and while many countries include socio-economic issues in their legislation, few have a clear approach as to how to go about it. However, now that herbicide-tolerant maize has been introduced in many countries, including South Africa, there is a growing body of ex-post data concerning socio-economic impacts. On balance, the findings are that herbicide-tolerant maize has had an overall positive effect. Measurable benefits include increased farm income, higher yields, and reduction in labour for manual weeding. Small-scale farmers in South Africa have particularly valued having more family time as a result. So we can reach the final conclusion that T25 can be safely cultivated in southern Africa. Note, however, that each herbicide-tolerant event should be assessed on a case-by-case basis. However, the methodology that I've shown you here can be easily followed for other events. Thank you.